Alright. So nothing from homework or anything. We made it up through, we actually are in chapter 8, and that's what I want to focus on tonight. So don't leave until you get the practice test. I don't know if you guys remember, the actual test is happening next Tuesday. Remember this? Not Thursday. Thursday's review day. No. So remember, what's next week? What's special about next week? It's the last week of classes. Because then after that, it's going to be finals. Holy crap. Feels like just yesterday we were going over the syllabus, and now we're almost at finals.
Yeah.
Last picture. Should take one at the beginning and see.
He already has one.
Okay, so there's no questions from homework. I'm going to jump. What I want to focus on today is chapter 8. We went over it really quickly last time. I want to come back in a little more in depth this time. I'm going to actually do something a little different. I'm going to give you the practice test and ask you to work on this section with the graphic in class today. Because then you can do homework at home for practice later. Coming back into chapter 8. We have the basic skill of finding points. Okay, it's exciting watching somebody making a graph. Can somebody tell me what the point, what A's coordinates are?
2, 1.
2, 1, 1.
Yeah, why does the 2 come first?
Because X is alphabetical.
I love it. So you go alphabetically. This axis, unless you otherwise are told it's X, this axis is Y. But in general, this could be like the time axis. So sometimes you see this as a T axis, because it could be time. So if I throw a ball and I throw from over here to somebody else, it could be over time, where how high is that ball up in the air? So that axis in general could be almost anything. So if you work somewhere, it could be time versus profit. And of course, your profit function could go down here. That would suck. That means you're losing money. You have negative profit. It sucks. Okay, so what about this point here? What point is this?
-4.
So this was 2, 1. What's that again?
0,
Zero plus zero. -4.
Negative 4,
I've got a
0.
couple of options here. Yeah, some people tell me 0, -4, and some people tell me it's -4, 0.
No, the second one. The one on the top.
Hey.
The one on the top. Because do I move up and down at all? And which variable controls up and down? Y. So when I move up or down, that's Y changing. But Y doesn't change at all. Y is 0. I don't go up and down at all. I only go back 4. That's X. I moved on the X-axis 4 back. You guys with me? Cool.
Want me to handle that?
Hey guys, there's a vent here. Thanks. Alright. It's not their fault. They don't know that the door has got a freaking hole in it. You gotta look at that planning. Alright. So it shouldn't be a big surprise if I ask you what point is that.
0, -0.
Yeah, I don't move left and right at all, so X is 0. And I really want you to see how this is not even purely a mathematical idea at all. It's just how do I get from there to there? Do I move left and right at all? No. You just drop 2. So the dude that controls left and right is 0, because it doesn't want you to move that way at all. And the dude that controls up and down is -2, because he wants you to go down 2. Bam. So on that level, it's not even math. It's just get me from here to there. So it could be very well, sometimes you'll see problems where you have, here's your house, and here's the convenience store. How do you get there? You go 2 blocks over and 1 block up. Or you can go 1 block up and 2 blocks over. Right? That's exciting. But, I mean, that's exactly the kind of problem it could represent. So this is not purely a mathematical idea. Latitude, longitude, we talked a little bit about last time. Sort of the same idea as blocks, to tell you honestly. Okay, how are we doing so far? So on one level, it's kind of like, okay, that's interesting. But the next level of this, the reason why you have to be able to find points is because what we want to do, every time you learn a new function, so right now we know very few functions. Well, you're going to start to learn more and more functions. And whenever you learn a new function, the first thing you're going to do with it is graph it to see what the hell it looks like. So I want to do a little bit different something today. Before I give you the practice test to work out, I want to show you some freakier functions than you'll see in the homework on a test, just to show you the next level of this, because sometimes it helps the motivation. If all you see are lines, it starts to get a little boring, like, yay. I want to see some freaking parabolas. I want to see some weird stuff. I mean, it's not even weird. You start to get some, remember that comet I showed you? And it traced out like a bunch of
That was a parabola.
leaves? That is a neat function that requires the use of trigonometry. And it looked like a spirograph game, remember, with the gears? Some of you guys said you remember that game. That it's not a game, but it's all the gears in there. Okay. So, let me try something I tried last time. Let's see if you guys can go with me. So, anytime I have a collection of points given to me, I can plot them. And they can represent, like, where my friends are. They got that stupid thing on the phone. Where are you? I can see where you are. So maybe this is where a friend of mine is, and there's another friend of mine, there's another friend of mine, and they're all converging on me like, oh shit. Yeah. So I really want this to make sense. Anywhere I get a collection of points, I can plot them on the graph, and they could mean whatever they mean. Where people are, where boats are out in the ocean, where planets are up in the sky, whatever. You guys kind of with me? If I get a point for something, I can plot it. And I get another point for something, I can see are they close to each other, and I can draw a line to see are they going to hit each other, stuff like that. That's where we're kind of going. So, one place that I can get collections of points is from relationships between X and Y. So, let me actually try something a little bit more direct. Now, if I ask this next question, that is some weird answer, what does that say?
X equals 3 times Y.
That was a very strange answer because it says not exactly that at all. What does it say again?
Y
I mean 3
equal
times
3 times X.
That was really weird. So, but think about what that really means. That means whatever X is, Y is 3 times as big. Right? That's really what it says. That's really what it says. So if I had, so then we can start making these little tables. And this is how we investigate this function. We say, what do you do to stuff? If I throw something in you, what's going to come out? And do I start to see a pattern? So if I throw 0 in there, poor little 0 dude, you triple him and he's, what? What's 3 times 0?
0.
0, thankful. Right? I got nothing. Can you stretch it and make it something? No, sorry. Try to do that every month with your budget. What about 1?
3.
Yeah, 3 times 1 is 3. So every time I'm putting something... Now, where are these numbers coming from? Where'd 0 come from? Where'd 1 come from?
Your mind.
From wherever the hell I want to. Right? This says the y piece of the point. So I have this point, x, y. The y piece of the point is 3 times whatever the hell the x piece is. And I can make x whatever the hell I want to. That's what x really represents, right? It represents all possible values. When it's in an equation, it might mean just one thing that makes that equation true. You guys kind of with me? Yeah. But in this case, x is whatever the hell I want to. And the minute I make x something, y has to be a certain something of it, right? So if I make x 1, y is going to be 3 times 1. So y is 3. That's crazy. What if I make x negative 1? Y is 3 times negative 1.
Negative 3.
Negative 3. Can you see me?
Yeah.
And if I make y equal to, if I make x equal to, what Jeff? 3.
Y will be 9.
Y is 9. So you can keep going forever until you go crazy, right? You guys with me? Okay. And then you can plot them. So on one level, I just got points just because I have a relationship between x and y. If I make x something, y is related to it. So I get a bunch of points. Anytime I get points from any freaking where, I can plot them. And somehow, because they came from this equation, it's going to be a visualization of this equation's answers. That's what that really is. How many answers does this have?
A lot. Forever.
Forever. In fact, in between these two answers is an infinite number of answers. Because I can make x 0.1, I can make x 0.01, I can make x 0.001. You with me? How long can I do that? For frickin' ever. So there's an infinite number of answers between every point. It's like, oh my god. I don't want to go there. I don't want to freaking have this infinite long list of answers. That's my whole life. Screw that. I want to get the main points, some nice whole numbers. When I plot them and I draw the line, I catch all those middle points. So for example, just freak you out. What if I made x 0.2? I could do that. I can make x whatever. I can make x square root of pi. Some weird ass shit. But if I made x 0.2, y's got to be
0.6.
0.6. 3 times 0.2, right? Alright, so we'll see how that comes into play here in a minute. So if I try to graph these things, holy crap, scales for that. Alright, so if I graph 0, 0, where's that?
Center.
Middle.
Right in the middle, right at the origin. So that's 0, 0, 1, 3.
Right 1.
Good, right 1,
Up 3.
up 3. Cool. And see how I didn't make a point here? There's no point there. You're not done moving around at that point. I go over 1, don't make a point yet. Up 3. Now that's the point, 1, 3. Negative 1, negative 3.
Down 1. Left.
Careful. Back 1.
Go back 1.
Down 3. I love it. The first number is x, y, left, right. Second number is up, down. Right? 3, 9, I don't want to do it. I don't need to. Right? I only really need 2. You do a third one just to make sure that it's still in a straight line. If that point was there, I know I screwed up somewhere. So you have a third point to check. And then a point, 0.2, 0.6. I don't want to plot that. It's free. So here's my line. But if x is 0.2, it's right there roughly. And the output is roughly 0.6. So when I draw that in, when I draw the line in, I'm connecting all the other billions and billions and infinite number of points in between. So I've just drawn the line through all the possible answers. And we just said there's an infinite number of freaking answers. So somebody tells you, what did you do today? You say, well, I answered something that has an infinite number of freaking answers. What'd you do? Or don't do that. That's a very geeky thing to do. How you guys feeling so far?
Great.
I really want to make that point understood. I could plot points from anywhere. They could represent anything. In math, most often they represent answers to an equation. And they show a relationship between x and y. This is a very simple relationship. Every point, whatever's here, that's 3 times as much. And you can see here what happens. When I move 1 over on the x, how far up do I have to go? 1, 2, 3. You guys see that? If I start here, if I move 1 over on the x, I got to go 1, 2, 3 to get back to the line. You guys see that? That's the pattern that's going on here, because every x is multiplied by 3. So y is going to change 3 times as much as x does. So if x changes by 1, from 0 to 1, y goes from 0 to 3. It changes by 3 times as much. How are we doing? Some of you guys are like, well, yeah, it says 3 there. But really, that's what you call the slope. That's going to be next semester. But that's where it comes from, just seeing how much it changes. So have you guys ever been down to like Mission Hills, or where else is really steep? That's where, closer to where I live. That going to the airport, you know that one place they have the stop sign, and then you basically go like this. And you've ever seen like, ever seen... What was that? Ever seen signs that say like 7% grade? ahead?
Yes.
So you guys, especially if you're driving out in Colorado or somewhere where there's a lot of mountains, and you see the runaway truck ramp, and you're like, oh shit. 7% grade. What is 7% as a fraction?
700.
So what 7% means is that if you run, if you go 100 in this direction, you'll go 7 up. For every 100 you go over, you go 7 up. You guys got it with me? And then that makes a 7% grade road, either up or down. Right? And down's where you want to watch out for the runaway trucks. You should check your brakes. You guys got it? I mean, that's
What if it is down?
Second,
How they write it?
it's still 7% grade. If you go up the thing or down the thing, it's still the same level, right? I don't care which way you go on it. That's the road. So this is 0% grade. 7% grade means I go 100, 7. 100, 7. That would be 7% grade. You with me? And some of you guys realize 7% grade is decently steep. So it doesn't take a lot to make it steep.
Yeah.
You don't want to see any 15% grade. That's where you're like, no.
Really?
Really?
Okay, I get it now.
Believe it or not, I mean, if you've ever seen these grade signs, if you've ever seen, if you haven't, I'm sorry.
I used to live on an Alpine, and I used to see those signs.
There you go. And what's the highest when you saw it?
16.
16? And that's pretty good. Yeah, shit. Alright. Alright. So, what if I had this here? Let's do one more like this. Can somebody give me one answer to this? So an answer, if you give me an answer, what does an answer entail? What do you have to actually tell me for an answer to this? How many parts are there to this?
3.
2 parts.
There's 2 parts. I got to know X, I got to know Y. So that's why every point has 2 parts. So what's one answer? What's one possible answer to this?
5 minus 1.
0.
Good. 5 minus 1 is 4. You guys see that? So all I'm doing over there, I didn't do it that way. We just figured out an X value when we saw what Y was when X is 0, when X is 1. We can do the same thing here. If X was 7, what would Y have to be?
3.
3. That was neat. And so, what else? Let me give you another one. 6 minus 2.
8, 4.
Yeah, 8 minus 4. I love it. 4 minus 0. Right? You can go forever on this. Right? Because there's an infinite number of answers. 4.7.
0.7.
0.7. 4.7 minus 0.7 is 4, right? 0.7's cancel. You with me? So, I mean, you can go 4.83946, right? That's the infinite part. I don't care how far you go out. There's always an answer for it. And then how do I graph this?
You
This is going to suck a little
5
bit.
to the right.
You go up to 7.
right.
Oh, I'm thinking backwards. 4, 1. There you go. So 5, 1. Where would 5, 1 be?
5 to the right.
Yeah, 5, 1, 2, 3, 4, 5.
1 up.
Up 1. 7, 3.
7, right.
Yeah, 7 on the x-axis. So 1, 2, 3, 4, 5, 6, 7.
3 up.
Up 3. And then 6, 2. It's going to be right in between.
6.
6, 2. So there's my little line already happening, right? 4, 0.
8, 4.
I know, I skipped it. 4, 0.
4 on the
1,
right.
2, 3, 4.
Stay.
And then go up and down roll, right? And thankfully all my points are lining up. Especially if you draw a little bit crooked, make it big. Cool. That's why on a test I'll always give you graphs to plot on, because I know, look at me, my scale's horrible. It's not going to make you make your own scale, because then you're like, why is it curving? Alright, how are we doing so far? That is the true basics of graphing. You collect your points from the equation they give you, and then you use the basic skill of plotting those points, and then you connect the dots. So let's do a more interesting function. Let's do a more interesting function.
Scary.
Sorry, I didn't get that.
It was Y-U-X.
Sorry, you were in class. All right. So you guys help me out here. So they give me a good number to start with. So what's different here?
The exponent.
Good. The x is being squared. Anytime, it sounds like a no because I'm sounding like talking very slowly. Anytime, I love how nobody's writing this down. Anytime that the powers are first powers. You understand? There's a 1 here and here. You with me? There's an understood 1 here, right? This x to the first power. It's going to be a straight line. Anytime it's anything different, squared, cubed, 1/2, square root, it's going to be some kind of a curve. So that's how you make curved graphs, is you make sure at least one of your exponents is not a 1. It's got to be a 2 or a 3 or a -2 or a 1/2 or something weird. You guys kind of with me? Some of you guys might know what this is going to look like. I don't know. You guys know what a squared function kind of looks like? Let's find out. So I don't care what the hell it is. I don't care. You could pick something for x or y if it's easier. But you guys see how this is set up to be y is x squared. So I want to know what x is. And then y comes popping out. So give me a value for x. 1. Sweet. So we'll say that's the first. So what is y when x is 1?
-4. -3.
-3. 1 squared is 1. -4 is -3.
0.
0 is always a good one to plug in.
-4.
So if I plug in 0, 0 squared minus 4,
-4.
-4, right? The 0's gone. You guys with me? What else is good to plug in there?
-1.
I like it. You always want to do some negatives, 0, some positives. Especially if you don't know what the hell it looks like. We'll do a mixture. So here's where things get a little bit weird. Let's see if you guys are with this. You guys try to figure out, let me write down what that is. That's 0, -4.
You have
Careful.
-3.
Try to figure out what goes here.
2.
Don't say anything, because that's wrong. You probably want to actually try it out.
-5.
-3.
Actually positive. Positive zone.
No,
No,
it's
negative.
-3.
No.
Same point.
Do the work before you say it.
-6.
So let's try it out. What's the function say you have to do to x? What's the function say you have to do to x?
Square.
Square it. So I got to square whatever x is.
No, it's not positive.
-1 times -1 is
I like it. So -1 squared. I don't do it like this. I got to square -1. And anything squared is going to come out positive, right? Or at least 0. -1 squared is 1. -1 times -1 is 1.
-4.
1 minus 4, -3. So it's really kind of freaky that 1 goes to -3 and -1 goes to -3. That's the curve. That's why it's parabolic. It curves. A line can't do that. If it's -3 here, it's going to be something different everywhere else. You with me? But this dude can repeat because it curves back on itself. Neat. I guess we're with me or not. I'm going a little further than our curriculum, but it just makes sense to. And if it doesn't for you, it's too bad because I am. So you guys try 2 and -2. Don't say anything. And then we'll try to graph it.
Zero.
How can I make that clear? So what do you get when you plug a 2 in there?
You get 4.
Okay, you get
Negative
4
4.
minus 4,
0.
0. And of course, when you plug negative 2 in there,
Same thing.
you get 0. So whenever I get it, when I plug a 7 in there, I'm going to get the same damn thing when I plug a negative 7 in there, because the square is going to make them both 49. You guys see that? So it's going to have a lot of repeats, whereas a line's got to just keep going in opposite directions forever. A square actually kind of goes the same way both ways. It's kind of neat. This one's going to actually, this one's actually going to open up like that. So let's see what it looks like. Let's see, 1, negative 3.
1 to the right, down 3.
Then I got 0, negative 4. Oops. Kind of gave it away.
Yeah, down 4.
Don't move left and right at all. Move down 4. Negative 1, negative 3.
Go to the left 1,
Yeah, back 1.
down 3.
Down 3. And then 2, 0.
Right. 0.
Yeah. Over 2 and then up, down, not at all.
Stay.
And then negative 2, 0. Back 2 and then up, down, not at all. How you guys doing? This is so obviously not a straight line, right? Doesn't mean you made a mistake. It's because the degree is not 1. It's a square on one of the variables. And this is what it looks like. It looks like a big U. So that's what you call a parabola. No, it's a parabola. Looks like a parabola, but it's a parabola. All right, so yeah, I don't know if how many of you guys have heard of that. I think I said it earlier. You say very often it's parabolic. When you throw anything to somebody, it's going to follow a parabola. Right? Throw a baseball somewhere, it's going to have a certain height that it reaches, and then it comes down. So this one's actually like a roller coaster, maybe, or something, right? It's got a minimum point, and then it's back up. Maybe it's my company, how much money we made. Oh shit, we're losing money. Oh, thank God. Right? That pretty much sums up the recession. Oh shit, okay. Okay, how we doing? So, let me give you the practice test, and what I want you to do is to try out 7, 8, and 10. Number 7, 8, and 10. Do number 7, 8, and 10.
Hey, which number? 7 what?
7, 8, and 10.
You want the graph?
Seven, 8, and 10. So do problems 7,